So in this question, we've been told that a ball is projected vertically upwards from a point 6 meters above the ground. The highest point that the ball reaches is 39 meters above the ground. We're asked to find the velocity of the ball when it is initially projected. As always, let's start with a diagram just so we have a good visual idea of what's happening. So, initially this ball starts on a platform 6 meters above the ground. This is its flight path, and it's moving in an upwards direction to begin with. We're told that the highest point the ball reaches is 39 meters above the ground. On the diagram, that means it's going to travel another 33 meters from its starting point. I phrase it like that because we know with SUVAT, we must consider displacement, not the height or the displacement above the ground, but the displacement from the starting point to the end point that we're interested in. From where the ball starts to its highest point is going to be 33 meters. And now this is the first place students will lose marks here. They want to use the 39. They haven't drawn a diagram. They don't realize that 39 now needs to become 33. Let's collect our correct SUVAT variables. So the displacement is 33. We don't know the initial velocity, it's what we're looking for. But we do know the velocity when it hits its highest point is going to be 0. The acceleration in this scenario is acceleration due to gravity, and we'll say it's negative 9.8. And t is an unknown time, which we don't need right now. A formula that uses S, U, V, and A is going to be v squared equals u squared plus 2as. We'll go ahead and substitute our values in. And when we rearrange, we see that u is going to be the square root of 19.6 multiplied by 33. And that gives us an initial velocity of 25.4 meters per second. Part B of the question asks us to find the time it takes to reach the ground. So this is a different part of the journey. We're going all the way from the point of projection to when it hits the ground. The displacement this time is -6. Our initial velocity we just found to be 25.4. Final velocity is unknown. Acceleration due to gravity, -9.8. And we're looking for the time here. We want the formula that uses SUAT, and that's our popular S equals UT plus half AT squared formula. Substitute the variables in there and you'll recognize and hopefully anticipate a quadratic equation. If we rearrange and solve, and you can use any technique here, whether it's completing the square, factorizing, using the quadratic formula, or the equation solver on your calculator. Probably the sensible approach in applied, just use the equation solver to get our values for t. We get t equals negative 0.225 or t equals 5.41. Negative time would not be sensible, so we eliminate that as an option, and here we have the time for the ball to reach the ground after it's projected is 5.41 seconds.